Our project is the leak detection system via infrared sensors. So what we will be doing is taking thermal images with an infrared camera. We will be performing image processing on those thermal images, and we will be uploading those images to a user web interface. This user web interface will allow our potential user to access the data collected by our leak detection system, and we'll upload them onto a GPS-enabled map. Our leak detection system will be implemented by city administrators who are seeking to lower the overall level of energy consumption of the city itself. Our leak detection system would specifically find leaks within a building using an HVAC system. By finding this information and relaying it to a city official, the city officials will be able to use necessary techniques in order to fix these leaks in order to lower the overall level of energy consumption, leading to saving on high energy costs.
So for my portion of the project, I'm going to be working to get all of the different components that we have to speak to each other. And most of that is going to happen through Bluetooth, but what we have implemented right now is our wireless file upload from our Android device that will be on board with the user, and it uploads to Amazon's web servers, which we will be using as the backend with our web client. Right now it works with user interaction, so when I press this button, it brings up files for me to choose from, and we'll upload this picture with the Ivy, and it's uploading. It's now done, and when we go check the web server, it should be there, ready for us to use. On the Amazon interface that the upload worked. This is the picture we just uploaded, and when you open it, there we go.
The system is the image processing portion, and the way that we are implementing that is to look for blurry edges on the thermal images, because the walls and the windows and the doors on a building all have different temperatures. They all heat and cool at different speeds, and so there's going to be a sharp difference between the wood colors of these parts of the building on the thermal image. So if we look for edges, we can easily tell apart the portions where windows and doors exist on the building. And if we look for blurry edges, we can tell where leaks are, because when the air is leaking out of a window, say, then it will cause a more gradual change in color than the sharp edge that a window would normally cause, and that's what we're going to be looking for. And so the first step to that is to implement an edge detector to understand where the walls are and where the windows are, and this will also help us to understand whether a full building is in view or not.
The Canny edge detection algorithm, which you can see when I run the code. So the way that Canny works is to first filter the image and then work with a lower and higher threshold of pixel intensity, usually with a ratio of 3 to 1. Pixels below the lower threshold are thrown out of the image, while pixels above the upper threshold are taken as an edge. And as you can see, as I change the minimum threshold, we can begin to see less extraneous edges and more of the outlines of where the windows and doors are.
The MSP430 uses button interrupts, which trigger timers in order to generate PWM to either change the direction of the servo to turn clockwise or counterclockwise. By increasing the PWM to 1.7 milliseconds, the servo will rotate counterclockwise as fast as it possibly can. Similarly, decreasing the PWM's pulse width to 1.3 milliseconds will rotate the servo in a clockwise direction at the fastest speed.
Aside from simply mounting an infrared camera on a vehicle, our system must also be able to control the camera's position. The camera will need to rotate horizontally so that it can see both sides of the street, as well as adjust its vertical angle to see multiple floors of taller city buildings. The position will be controlled by both user inputs as well as algorithmic feedback. The simulation shows the camera rotate horizontally and then adjust its vertical angle to the desired position. The range of motion shown here allows the camera to take images of multiple floors of the building. The miter gears, shown in this frame, rotate the shafts, allowing the camera to see both sides of the street. The system's dynamics allow for our camera to take a wide range of images.